p.m.
Good morning everyone, I'm Madeline Reyes and I would like to share you about semiconductors. In early modules, we have learned about conductors and insulators. Can you still recall what conductors are? How about insulators? Conductors are materials through which electrical charges flow easily because they have many free electrons which are not strongly attached to their nuclei. Insulators are the opposite of conductors. They do not conduct electrical charges. Rubbers and plastics are examples of insulators. How about those materials that are neither conductors or insulators? Is it really possible to have materials whose ability to conduct electricity lies between conductors and insulators?
Yes.
Yes. They are called semiconductors. They are poor conductors of electrical current at pure state, especially at low temperatures. But they gain electrical conductivity where certain substances called impurities are added.
Diyan, ikaw sa dyan, no?
And I'll be right back after a short break.
Nakuha yung game ko.
Examples of semiconductors are silicon and germanium. These elements have atoms with a valence electrons of 4, which means that the atoms have 4 electrons in their outermost shell. These atoms do not easily gain or lose individual electrons. Instead, the semiconductor atoms share the 4 valence electrons with other atoms, thus forming a covalent bond. When electrons are added, the result is negative or n-type material. N-type materials are produced by adding pentavalent element to the semiconductor. Pentavalent elements have 5 valence electrons. N materials have excess electrons and p-type have deficiency of electrons, called holes. When n-type materials and p-type materials are joined, a diode is formed. The majority charge carriers in an n-type material are electrons represented by the dots. The majority charge carriers in an n-type material are protons represented by the holes. What if we add a third layer? Then a transistor is formed. We create a p-n junction diode by joining together 2 pieces of semiconductor, doped in type and p-type. This causes the depletion zone to form around the junction between the materials. The depletion zone controls the flow of electron and behavior of diode. When we apply potential difference between the 4 wires, we tend to pull the electrons and holes away from the junction. This makes it even harder to cross the depletion zone. The polarity of the voltage applied makes diode reverse bias. When the voltage is applied the other way around, we push the electrons and holes toward the junction. The recombined charges then pass through the junction. With this polarity, the diode is formed bias.
짜릿함을 나눠봐 2 p.m. Get ready to share the beat. 우리 다 함께 비트를 모아 올림픽 전사를 위해 함께 응원해 비트를 타고 최고의 경기 위하여 숨이 차오르는 이 순간 Get ready to share the beat 나를 이기는 이 순간 Let's celebrate the beat 모두가 원하던 짜릿한 승리를 맛볼 거야 Are you ready? Can you hear the beat? It's time to celebrate Let's share the beat It's time to celebrate Can you hear the beat? It's time to celebrate